Another mystery buried deep in the hills of eastern Washington keeps resurfacing, a bottomless pit said to be a pathway to the paranormal.
For decades, Mel's Hole existed somewhere between an urban legend, a paranormal mystery, and a story that refused to disappear. Somewhere in the remote wilderness of Washington state, according to the legend, there was an ordinary-looking opening in the ground that supposedly had no bottom. Objects could be dropped into it and never heard again. Animals allegedly refused to approach it, and people who tried to understand it claimed they encountered strange obstacles, government attention, or unexplained interference. For years, the story survived almost entirely through radio broadcasts, internet forums, and second-hand accounts. But then, technology changed. Advanced LiDAR, ground-penetrating radar, electromagnetic sensing, seismic imaging, and artificial intelligence created a completely new possibility. Instead of asking whether Mel's Hole was real, researchers could ask what was actually beneath the ground. And before we go any further, please subscribe to the channel and help us reach our goal of 5,000 subscribers. Because what began as a strange story about a bottomless hole may lead us towards something far more mysterious, buried beneath the earth. The story entered popular culture in 1997, when a man calling himself Mel Waters contacted the late-night radio program Coast to Coast AM. The show had become famous for discussing UFOs, paranormal encounters, unexplained phenomena, and strange stories from listeners across America. Mel's story immediately stood out because he didn't describe an alien spacecraft or a supernatural creature. He described something much simpler, a hole. According to Waters, the opening was located on property he owned in Washington state, and from the surface it apparently looked relatively ordinary. But beneath that small opening was what he claimed to be an impossibly deep shaft, one that seemed to continue downward without reaching a bottom. According to Mel's account, curiosity eventually got the better of him. He began experimenting with the hole, lowering a weighted line deeper and deeper into the darkness. The story became extraordinary when he claimed that more than 15 miles of line had supposedly disappeared into the opening without reaching anything. There was no obvious impact, no splash, no rockfall, and no clear indication that the weight had ever reached a surface below. To understand how extraordinary that claim was, consider the Kola Super Deep borehole in Russia, which reached approximately 7.6 miles beneath Earth's surface after years of engineering, drilling, specialized equipment, and enormous financial investment. Mel's story suggested that an opening in rural Washington was somehow deeper than humanity's deepest engineered borehole, but the depth was only the beginning. The legend claimed that people had experimented by throwing objects into the opening, including tires, refrigerators, animal remains, and other discarded materials. According to the stories, nothing ever seemed to accumulate at the bottom. There was no obvious echo, no visible obstruction, and no sound of impact. Everything simply disappeared. That detail transformed the hole from a strange geological feature into something almost impossible to explain. If the opening was simply a deep cavity, objects should eventually encounter rock, water, debris, or another surface. Gravity does not make matter disappear, yet according to the legend, the hole behaved as if it were connected to something far deeper than anyone could measure. The story became even stranger with reports about animals. According to versions of the legend repeated over the years, dogs supposedly refused to approach the opening, sometimes growling or backing away as if they sensed something humans could not. Birds were allegedly reluctant to fly directly over it. These claims were never established as scientific evidence, but they became an important part of the mythology surrounding the location. Stories also began circulating about older indigenous traditions, supposedly warning people away from a dangerous place in the region. However, there is no reliable evidence proving that a specific Native American tradition described Mel's Hole as a portal or bottomless shaft, and these claims should be treated as part of the later folklore, rather than established history. Scientists who heard the story had an obvious reason to be skeptical. A vertical cavity extending miles into the Earth's crust would face enormous physical stresses. As depth increases, pressure rises dramatically, temperatures become higher, rock can deform, fractures can develop, and unsupported cavities can collapse. A shaft several miles deep is not simply a larger version of a cave. It becomes an extreme geological and engineering problem. The Kola Super Deep borehole demonstrated exactly how difficult deep penetration becomes. Engineers eventually encountered temperatures far beyond their expectations, and the project had to confront geological conditions that made continued drilling increasingly difficult. That made Mel's claim almost impossible to accept literally. Yet, there was another possibility. Maybe the story had been exaggerated. Maybe the measurements were misunderstood. Maybe the line had become tangled or never traveled as far as claimed. Maybe the hole was actually a natural cavity whose dimensions had been transformed through years of storytelling. Or perhaps there really was something unusual beneath the region, something that had never been properly investigated. That uncertainty became the foundation of the legend. Nobody had to prove the impossible hole existed. All they needed was the possibility that something strange might be there. Then came the darker part of the story. According to Mel's later accounts, people connected to government or military organizations supposedly became interested in the location. He claimed that mysterious officials appeared around the property, and that access to the area eventually became restricted under unusual circumstances. One version of the story involved a nearby aircraft crash that supposedly provided a reason for authorities to control the area. Mel later claimed that he was offered money to leave the United States and was warned not to discuss what he knew. Eventually, he disappeared from public view, and the story became even more mysterious. There is no independently verified evidence establishing that a government agency actually seized the site or attempted to silence Mel, but the allegations became one of the most persistent elements of the legend. By the 2000s and 2010s, Mel's Hole had evolved far beyond the original radio story. Internet forums began discussing possible coordinates. Amateur investigators searched satellite imagery, and paranormal researchers debated whether the hole represented a geological anomaly, a secret military facility, an ancient underground structure, or something extraterrestrial. Every unexplained detail became another piece of the puzzle. A blurry satellite image could become evidence of a hidden facility. A failed expedition could become proof that someone was protecting the site. A malfunctioning GPS device could be interpreted as electromagnetic interference. The legend grew because every missing piece of information could be filled with speculation. But there was one major problem with almost every theory. Nobody could actually see what was underground. Traditional exploration would require drilling, and drilling is destructive, expensive, and extremely limited. A borehole only tells you what exists directly along its path. You could drill hundreds of meters and still miss a hidden chamber just a few meters away. A cave system could extend horizontally beneath the surface without ever intersecting the drill. If Mel's Hole was connected to something larger, traditional drilling might never reveal the complete structure. Then underground exploration entered a new technological era. Modern researchers began combining ground-penetrating radar, LiDAR, seismic imaging, electromagnetic sensors, magnetometry, thermal measurements, and high-resolution photogrammetry. Each technology sees the subsurface differently. Radar can reveal changes in underground materials. Seismic waves can show how structures transmit vibrations. Electromagnetic sensors can detect variations in conductivity and field behavior. LiDAR can create extremely detailed three-dimensional models of accessible spaces. Individually, these technologies have limitations, but together they can produce a far more detailed picture of what lies beneath the surface. And then artificial intelligence entered the process. AI does not literally see through solid rock, and it cannot magically reveal hidden civilizations or alien structures. What it can do is process enormous quantities of sensor data far faster than a human team. A single survey can generate millions of measurements, and different sensors may produce patterns that are difficult for humans to recognize. Machine learning systems can compare those datasets simultaneously, identify recurring geometric features, separate probable geological structures from anomalies, and highlight locations that deserve closer examination. Imagine the investigation beginning before sunrise. The landscape is quiet, the surrounding forest almost completely still, while technicians position sensors around the suspected area. Cables run across the ground. Monitoring equipment begins recording. Seismic pulses travel into the earth. Electromagnetic sensors measure subtle changes. Ground-penetrating radar produces layers of underground information. The first scans reveal exactly what researchers would expect: soil, fractured rock, natural geological boundaries, and countless small irregularities. Nothing looks extraordinary. Then the AI begins combining the datasets, building a three-dimensional representation of the underground environment layer by layer. At first, the model looks like noise. Then, a vertical anomaly begins to emerge. It isn't immediately identifiable as a tunnel or shaft, but the structure appears to extend downward through the surrounding geological layers. The system isolates it and compares the feature against nearby formations. Another scan produces a similar result, then another. The researchers increase the resolution and examine the anomaly from different angles. Suddenly, the old legend becomes scientifically interesting for an entirely different reason. They still don't have proof of a bottomless hole, but they may have found an underground feature that deserves closer examination. The AI begins highlighting areas where the geometry changes. Some regions appear to contain cavities. Others show narrow vertical zones surrounded by different material densities. A few features seem unusually symmetrical. That doesn't automatically mean they are artificial. Nature can produce remarkably geometric structures through volcanic activity, erosion, crystallization, faulting, and mineral deposition. But when several independent sensors detect the same boundary, the probability that researchers are simply looking at random noise becomes smaller. The deeper the model goes, the more complicated the underground picture becomes. One cavity appears elongated, another seems nearly circular, a third feature appears to connect with the main anomaly. The AI doesn't label these structures as alien or artificial. Instead, it assigns probabilities based on the available evidence. Natural cavity, possible. Fracture system, possible. Man-made structure, uncertain. Unknown formation, significant uncertainty. And that final category is what captures everyone's attention, because unknown doesn't mean something supernatural. It simply means the available evidence is not yet sufficient to explain the feature. That distinction is critical. For years, the mystery of Mel's Hole has been surrounded by extraordinary claims, from portals and secret bases to extraterrestrial technology. But a genuine scientific investigation would have to separate those stories from measurable evidence. If a subsurface anomaly exists, the first goal would not be to declare what created it. The first goal would be to determine its dimensions, composition, age, and physical properties. Only after those questions were answered could researchers begin asking whether it was natural, ancient, modern, or something else entirely. And this is where the legend takes an unexpected turn. Because the most fascinating possibility isn't necessarily that Mel was telling the truth about a 15-mile bottomless shaft. It is that his story may have grown from something real but misunderstood. Human stories change with time. A deep cavity becomes a bottomless pit. An unusual magnetic reading becomes evidence of a secret machine. A restricted area becomes proof of a government cover-up. A strange geological feature becomes an underground civilization. After enough retellings, the original observation can become almost impossible to separate from the mythology built around it. Now imagine the AI rendering one final section of the underground model. The surface is ordinary. The upper layers are ordinary. But deeper down, several independent datasets begin converging on the same region. Density changes, electromagnetic behavior shifts, seismic reflections become unusual. The system highlights the location in a different color, not because it knows what is there, but because the statistical pattern is significantly different from the surrounding geology. The researchers zoom closer, expecting another natural fracture or mineral boundary. Instead, they see a shape. Not an alien, not a machine, not proof of a secret government facility, just an unidentified underground structure. And suddenly, the question that began with a late-night radio call in 1997 becomes relevant again. What if Mel's Hole was never truly about a bottomless pit? What if the real mystery was what existed around it, beneath it, and beyond what anyone could see? For decades, people asked whether Mel's Hole had a bottom. But perhaps that was the wrong question all along. The deeper mystery is whether there was ever a structure beneath the Washington wilderness that inspired the legend in the first place. Modern technology may not prove every extraordinary claim surrounding Mel's Hole, but it can do something far more valuable. It can separate mythology from measurable reality. And if future surveys ever confirm a massive, unexplained underground system beneath the location associated with the legend, the story would suddenly become much more than an internet mystery. Because then, for the first time, investigators would have something that Mel Waters never had. Data, the AI scan that changed everything. The plan was simple on paper, but nothing about it was ordinary. In early 2024, a small, privately funded expedition assembled in secret. The team wasn't made up of TV ghost hunters or amateur thrill seekers. These were field engineers, former defense contractors, and underground mapping specialists, people who had spent their careers dealing with places most of us will never see. They brought with them equipment usually reserved for high-security infrastructure inspections, deep cave rescue planning, and military reconnaissance. But the heart of their operation wasn't human at all. At the center of the mission was a next-generation AI scanning system, a hybrid of photogrammetry, LiDAR, ground-penetrating radar, and electromagnetic field sensors. This wasn't about taking a few blurry photos of a mysterious shaft. This was about creating a full 3D reconstruction of Mel's Hole, right down to the millimeter, and letting the AI analyze it in real time for patterns human eyes might miss. Before lowering any equipment, the team set up a perimeter around the site. Every device had redundant power supplies and shielded data storage designed to survive electrical surges and interference. The rig they built at the edge of the opening looked like something between a deep-sea winch and a satellite launch platform. Attached to it was a cylindrical scanning drone bristling with sensors, its exterior coated in matte black to reduce glare. The first seconds of the descent were uneventful. The drone's lights cut into the darkness, revealing walls that were far smoother than expected, almost polished, as if something had cut through the earth with surgical precision. The AI immediately flagged this as anomalous. Natural shafts, even volcanic tubes, are irregular. This was symmetrical, consistent, intentional. As the drone went deeper, the AI began layering data. Photogrammetry mapped every curve of the walls. Thermal sensors checked for heat sources, and electromagnetic readings scanned for disruptions in the surrounding field. At 200 feet, the AI noticed something strange: a complete absence of microfractures. In geology, all things will show stress lines, the scars of shifting Earth. But here, the walls were flawless. The AI ran a material density check using the resonance data from the pings it emitted, and the results were shocking. The shaft did not match anything in the local basalt sandstone composition. It was denser, stronger in places. It simply absorbed the signal. Then came the second anomaly. At around 340 feet, the LiDAR feed revealed horizontal features embedded in the walls. Thin, perfectly spaced ridges wrapping around the circumference like rings. Not random mineral deposits, not roots. The AI labeled them as structural reinforcement indicators, something you would expect inside a man-made tunnel, not in a vertical shaft costing countless resources in the middle of nowhere. As the descent continued, each foot revealed more questions than answers. At 500 feet, there was a spike in the values of the electromagnetic sensors for a brief moment, turning the compass on the drone completely nuts before it managed to stabilize again. The AI tagged it as localized EM distortion, probable active source. To put it in layman's terms, there was something down there radiating energy. Stopping for a while to allow the AI to process, the team found that its results were much harder to explain. Out of all the overlapping scans, it produced a preliminary 3D model for the first 600 feet. What showed up was unnatural, perfectly parallel walls, identical reinforcement rings every 50 feet, and, at 2 points, narrow horizontal openings leading into what appeared to be side chambers, too symmetrical to be caves, too precise to be accidents. The deeper the scan went, the more it looked less like a hole and more like a shaft, a constructed passage, something designed to go down and keep going. The AI still hadn't delivered on its most unsettling findings. As it processed the composite data, it began overlaying a faint heat map from deep within one of the side chambers. This tiny, steady, and warm signature wasn't geological warmth, but the sort you'd expect from something operating. It wasn't leftover debris. Also, it wasn't dead. They thought they were scanning a strange geological feature. What the AI showed them next would make some wonder if Mel's Hole had ever been part of nature at all. Geometry that shouldn't exist. When the AI's first full composite of the shaft loaded onto the team's main screen, it didn't look like any natural formation in Washington State or anywhere else on Earth. It was as if the ground had been bored through with machine precision. Yet, there were no signs of drilling, no tool marks, no debris piles that would have been left behind. The shaft's inner diameter measured exactly 14 feet across, from the first scannable inch to the last point. The drone reached not an inch more, not an inch less. The AI flagged this as statistically impossible in a natural void of this depth. Geologists on the team tried to dismiss it as coincidence, but the data didn't budge. It wasn't just consistent, it was perfect. As the AI model rotated, the symmetry became even stranger. Every 50 feet, without fail, the shaft was lined with thin, metallic ledges or rings, protruding no more than 2 inches from the wall. They weren't rough like mineral deposits. They were smooth, uniform, and equidistant, like the steps of some inverted ladder built for something not quite human. The density scans deepened the mystery. Most of the shaft's material was denser than the surrounding bedrock, but certain segments, precisely aligned with these rings, reflected signals in a way that suggested composite alloys. Whatever these metals were, they weren't native to the area's geology. Cross-referencing the readings with known metals in the U.S. Geological Survey database returned no exact match. The AI labeled them simply unknown material, high structural integrity. And then there were the anomalies between the walls. At 280 feet, the LAR picked up what looked like a horizontal seam, a perfectly straight line cutting a 4-foot-wide section across the wall. The AI's spatial reconstruction showed that the seam bordered an empty space beyond the wall, a void about the size of a shipping container. During the team's thermal overlay, it was observed that the void was not cold, but rather gently and steadily warm, a couple of degrees higher than the surrounding rock. Some entity within was holding heat, though for how long it had been shut away inside remained to be seen. And even more puzzling was revealed. 470 feet down, where the arch appeared to bulge from the wall in a half-circle curve, it wasn't a large one, maybe 3 feet wide, but whatever held it had the same metallic density as the reinforcement rings behind it. The AI detected another narrow channel branching away from the main shaft, sloping slightly downwards before fading from sensor range. By this time, the model of Mel's hole no longer resembled a vertical pit. Instead, it started looking like part of a system, an engineered complex created with intent and precision. The AI even constructed a structural stress prediction, which showed that the reinforcements could, in theory, withstand extremely high pressure, vibrations, and seismic activities. Whatever this was, it was not meant to collapse. After hours of taking a look at the model, one engineer on the team finally uttered what no one wished to say. "It hardly looks like something we are discovering, and more like something we are trespassing into." It was a thought that none could shake, for if the shaft had indeed been constructed, it had a purpose, and anything with a purpose has its creator. Yet still, the AI's work was far from over. As it concluded its next layer of scans, it began marking certain voids and wall sections with pulsing red indicators. The legend on the display read, "Potential access points." Access points to what, exactly? They were about to find out, because one of those flagged areas was more than just a void. It was a sealed chamber, and what the AI detected inside it would push this investigation into dangerous territory. The hidden chambers. The AI's pulsing red markers weren't random. They highlighted very specific zones along the shaft's walls where density, temperature, and geometry all shifted from the surrounding structure. To human eyes on the raw scan feed, these sections looked like nothing more than slight changes in texture. But when the AI overlaid every dataset, LiDAR depth maps, thermal readings, and electromagnetic variants, a clearer picture emerged.